A company produces steel rods. The lengths of the steel rods are normally distributed with a mean of 204.9 centimeters and a standard deviation of 1.1 centimeters. For shipment, 7 steel rods are bundled together. Find the 38th percentile, which is the average length separating the smallest 38% from the largest 62% of bundles. So let's start out drawing our normal curve, and we are trying to find the mean length, the average length of these steel rods that has 38% to the left. So this represents 0.38, and that means 0.68 will be up here so that the whole thing adds up to 62. 62%. So to start out, let's find out what this z-score is. So we need to find the z-score that has 0.38 to the left of it. Now I'm going to do this using the table, and I'll also do this using a spreadsheet. Using a normal distribution table, I'm going to try to find 0.38 as a probability. So that's in here in the middle of the table, and I'm looking around and I see 0.3821 and 0.3783. So 0.3, either 0.30, negative 0.30 rather, or negative 0.31, or split the difference and call it negative 0.3, and I can either call that 0.30, 0.31, or split the difference and call it 0.305. Now we need to convert this into a average length. So the conversion formula looks like this. Take the z-score you have, multiply it times the standard deviation, and add the mean. However, we need to use the central limit theorem because we're talking about the average of a sample size. So we're really calculating an x bar, and that means we need the standard deviation for x bar and the mean for x bar. Well, to figure out what those are, it's fairly simple. We just take the standard deviation that we're given, 1.1, and divide by the square root of that sample size. Now the mean for x bar is just the mean of the population that we're given. So that means x bar equals the z-score we found, either 0.3, 0.31, or split the difference, 0.305, times the standard deviation, which we are going to use 1.1 divided by square root of 7, plus the mean, 204.9. And throwing this all in to your calculator, let me do that. And if you have a TI-30X2S, you can plug yours in the same way that I'm going to do mine, or really any scientific calculator. So negative 0.305 times 1.1 divided by square root, find your square root button, of 7 plus 204.9. And I get 204.77. 204.77. Now, let's look at how to do this problem on a spreadsheet. I could figure out what the z-score is by throwing 0.38 into the norm s_inv. All right, let's try this. Norm.s_inv function 0.38. And you can see that gives me the z-score that we used earlier. And again, I could round that to 2 decimal points and use negative 0.31. Negative 0.305 is also a good estimate. All right, now I can convert that into an x bar, an average length, using the formula we did before. Now, if I didn't want to go through that conversion, I could use the norm.inv without the s in it it'll do the conversion for me. So I can plug in negative 0.38, the mean, which is 204.9, that's the given mean. The standard deviation, and again, I have to be careful, I'm using the standard deviation for x bar, not the standard deviation as it's given. So I have to do 1.1 divided by the square root of 7. And in one fell swoop, it gives me the correct answer, 204.77.